This video is intended to explain how the answer was arrived at for number 2. So we're going to talk about how we determine the trig, the algebraic models for the trig functions given the graphical model. So first of all, we're going to determine the parameter a that goes in front of each trig function. In this case, the parameter a is the amplitude. To determine the amplitude, we want to recall something from earlier in the course, that the amplitude is equal to the maximum minus the minimum divided by 2. So the maximum of this trig function is 2. The minimum is negative 2. So to determine the amplitude, we're going to go 2, take away negative 2, which is 4, and divide by 2. And so there we have it. The amplitude is equal to 2. Now let's determine the value of k, the parameter k, which goes in front of x in our sine function. To determine the parameter k, we want to look at how many cycles occur in a period of 360 degrees. That is the normal period for a sine function. So let's draw a box around 360, from 0 to 360, which is where we usually see a single cycle of the sine curve. So here we have a window that looks at 0 to 360. How much of the sine curve are we seeing in this window? Well, as you can see, we only have half of the sine curve. In other words, we are seeing half of a cycle. This is the number of cycles that occur in this period from 0 to 360. This is the value of k. So k in this case will be 1/2. So now that we've determined the value of our amplitude, 2, and the value of k, which is 1/2, we can state that the function, the algebraic model for this function, is 2 sine 1/2 x. Let's go to 2b. To determine the amplitude for this function, we want to determine the maximum and the minimum, and then the difference between them, and divide by 2. The maximum in this function occurs at 1/2. The minimum occurs at negative 1/2. So let's work out the amplitude. So we have 1/2 take away negative 1/2, which gives us 1 over 2. So the amplitude is 2. This will be the parameter that goes in front of our sine function. Now, let's determine the value of k, which is the number of cycles that occur in the normal period from 0 to 360. Now, before we begin that, usually our sine function goes up and down and up and down. But notice this one starts down, so that tells us something else about our value for a, the amplitude. This must be reflected in the x-axis. So when we write our function, not only will we put 1/2, we're going to put negative 1/2 to indicate the reflection in the x-axis. Now let's return to our period. How many cycles do we see from 0 to 360? Let's draw a box around one cycle. There is one cycle of the sine function. Notice that it is reflected. How many of these cycles do we see from 0 to 360? This will tell us the value of k. As you can see, we have 1, 2, 3, and then 4. We've drawn 4 boxes around the 4 cycles that occur from 0 to 360. So this tells us that the parameter for k must be 4. Don't forget that k represents the number of cycles that occur in our usual period from 0 to 360. In this case, we have 4. So now that we have our two parameters, we can state that the function is f of x equals, don't forget the negative to indicate the reflection around the x-axis. The amplitude was 1/2 sine, and our k value is 4.